We're living in an age where robots are no longer the stuff of science fiction. They're in our factories, our homes, and even in our hospitals. But let's take a moment to pull back the curtain and see what's really making these machines tick. It's not just about nuts and bolts, it's about the microchips and neural networks that are essentially the brains of these robots. And when I say brains, I mean it. These chips are getting smarter, faster, and more capable by the day. Now, I know what you might be thinking. Okay, but what's the big deal about computer chips? We've had them for decades, right? True, but here's where it gets interesting. The chips we're talking about now aren't just processing data. They're learning, they're adapting, they're powering neural networks that mimic the human brain's structure, allowing robots to perform tasks that were once the realm of pure imagination. We're talking about robots that can learn from experience, recognize patterns, and even make decisions in real time. And if that doesn't sound like something straight out of a sci-fi movie, I don't know what does. But here's the thing. It's not fiction. It's happening right now. So in this video, we're going to dive deep into the world of these chips, their history, how they work with neural networks, and why they're the unsung heroes behind today's robotic revolution. Let's take a quick journey back in time to see how we got here. You see, the story of modern robots really begins with the evolution of computer chips. These little pieces of silicon are basically the brains of everything digital, from your smartphone to the most advanced AI systems. Back in the day, chips were pretty basic. The first microprocessors, like the Intel 4004 from the 1970s, could only handle simple tasks, think calculators or basic game consoles, but as technology progressed, so did these chips. Fast forward to today, and we've got processors that can perform billions, yes, billions of operations per second. That's what makes all the incredible technology we use daily possible, from gaming graphics to the AI in self-driving cars. Now you might be wondering, how do these chips go from basic math operations to powering complex AI systems? Well, the secret sauce is in the design and the incredible advancements in chip architecture. Over the years, engineers have figured out how to cram more and more transistors, the tiny components that do the actual computing, into smaller and smaller spaces. This is what we call Moore's Law, the idea that the number of transistors on a chip doubles roughly every 2 years, making our devices faster and more powerful over time. But the real game changer, the chips started getting smart. Enter the era of GPUs, graphics processing units, which were originally designed for rendering images and video. But someone had the brilliant idea to use them for AI because they're fantastic at handling parallel processing, which is exactly what neural networks need. GPUs became the backbone of AI advancements, especially in deep learning, where massive amounts of data need to be processed simultaneously. And today, we're even beyond GPUs. We've got TPUs, neural network processors, and specialized chips that are custom-built to handle AI tasks with incredible efficiency. These advancements are what allow us to train complex models and power the AI-driven robots you see today. So, we've got these powerful chips, but what are they actually doing? This is where neural networks come in. Imagine a neural network as a series of interconnected nodes, or neurons, much like the neurons in a human brain. These networks are designed to process information in a way that mimics our own thinking patterns. But instead of neurons firing off in your brain, we've got layers of these artificial neurons doing the heavy lifting in a computer. Here's the cool part. These networks can learn. They take in vast amounts of data, identify patterns, and then make decisions based on what they've learned. For example, if you feed a neural network thousands of images of cats and dogs, it'll start to recognize the differences between them. That's how you get AI that can tell whether your Instagram photo is of your pet or just a random animal on the street. But neural networks don't work in isolation. They need serious processing power to function. And that's where our advanced computer chips come in. You see, each layer of the network involves complex mathematical operations, and it takes a lot of these operations happening simultaneously to make the network function properly. That's why GPUs and TPUs are so crucial. They allow all these processes to happen at once, making the AI super efficient and capable of learning faster than ever before. So you've got this synergy happening. The neural networks bring the learning, while the computer chips bring the processing power. Together, they create AI systems that can learn, adapt, and even make decisions, something we're seeing more and more in today's robots. But how exactly do these two elements work together to create the robots and AI systems we see today? Think of the computer chip as the engine of a car and the neural network as the driver. The engine provides the raw power, the ability to accelerate, climb hills, and keep the car running smoothly. But without a driver, that power is useless. The neural network is the driver that steers, makes decisions, and adapts to the road conditions. It's the combination of these two, raw processing power and intelligent decision-making, that makes modern AI so powerful. When you're training a neural network, especially for something as complex as autonomous driving or robotics, the chip has to handle vast amounts of data. This data is processed in parallel, meaning multiple computations happen at the same time, something traditional CPUs just can't handle efficiently. That's why GPUs and TPUs are used. They're designed to manage these large-scale parallel operations, which is exactly what's needed for training deep neural networks. But it's not just about training. Once a neural network is trained, it needs to run efficiently in real time. This is where the specialized chips come in again. They enable AI systems to process information quickly and make decisions on the fly, whether it's a robot navigating through a crowded room or an AI assistant understanding your voice commands. So when we talk about modern robots, what we're really discussing is the incredible teamwork between cutting-edge chips and neural networks. The chips provide the power, the neural networks provide the intelligence, and together they create systems that are far more advanced than anything we've seen before. It's this synergy that's driving the current wave of AI and robotics innovations, making the sci-fi dreams of yesterday a reality today. The point is, whether it's in your home, your workplace, or even as a pet, robots are becoming an integral part of our lives. And at the heart of all these advancements are those powerful chips and neural networks working together to create machines that are smarter, faster, and more capable than ever before. But as exciting as this is, it's also worth pausing to think about where this is all heading. This brings us to some serious ethical concerns. For one, there's the question of autonomy. As robots and AI systems become more advanced, they're starting to operate with a level of independence that was unthinkable just a few years ago. But who's responsible when something goes wrong? If a robot makes a decision that leads to harm, whether it's a self-driving car in an accident or an industrial robot that malfunctions, where does the accountability lie? With the programmers, the manufacturers, the users. Then there's the issue of privacy. We talked earlier about how computer chips and neural networks work together, processing massive amounts of data to make decisions in real time. But where is all that data going? How secure is it? And what happens when that data is used to make decisions about your life, your job, or your health? The more integrated these robots become in our daily lives, the more data they collect, and the greater the potential for misuse or abuse of that information. And let's not forget the impact on human jobs. Robots in warehouses, on assembly lines, even in customer service, these are jobs that humans used to do. As robots become more capable, more efficient, and cheaper to operate, we're likely to see a shift in the job market that could leave many people without work. The sci-fi scenario of robots taking over is closer than we might think, and it's something we need to be prepared for. But here's the flip side. This technology also holds incredible promise. Robots could take on dangerous tasks that put human lives at risk, like disaster response or deep-sea exploration. They could provide companionship and care for the elderly, or assist in surgeries with a level of precision that surpasses human capabilities. The potential benefits are enormous, but we need to approach this future with caution, foresight, and a clear understanding of the risks involved. So, as we move forward into this brave new world, it's not just about the technology, it's about how we, as a society, choose to use it. The decisions we make today will shape the future of AI and robotics, and it's up to us to ensure that this future is one that benefits everyone, not just a select few. And there you have it, a glimpse into the rapidly evolving world of robots, computer chips, and neural networks. We're living in a time where the lines between science fiction and reality are blurring, and the choices we make now will have far-reaching consequences. Whether it's the potential for robots to change the job market, the ethical dilemmas of autonomous machines, or the incredible possibilities for improving our lives, the future of AI and robotics is something we all need to be aware of and engaged with. What do you think? Are we ready for a future where robots are an integral part of our daily lives? Or are there still too many unanswered questions? I'd love to hear your thoughts in the comments below. And if you're as fascinated by this technology as I am, don't forget to subscribe and check out my other videos on AI, robotics, and the tech that's shaping our world. Thanks for watching, and I'll see you in the next one.